Okay, so now next part is we're going to look at logarithms and doing algebra. And so we're just going to do some simplifications here. And here we can take logarithms and just multiply them like regular. So this is log x squared plus 3 log x, and log y minus 2x log x. Note that because there is nothing written down here, it implies it is a base 10. It's the common logarithm. Similarly, if I look at B part, I'm going to do some algebra here. One of the things I recognize is that this is similar to setting up a squared minus 4 over a minus 2. The natural logarithm of x here is a whole variable itself, so then I can factor this to ln x minus 2 times ln x plus 2 over ln x minus 2. These cancel, and so I'm left with this simplifies to ln x plus 2. Again, just to reiterate, this means log base ex is the natural logarithm. Okay, so another kind of algebra thing, if I want to make x the subject of this, that means I want x equal to stuff. So here's my x, so I need to get rid of this logarithm. If I want to get rid of the logarithm, I can conceptually think of it two ways. I can do the inverse to both sides, or I can rewrite it as a to the exponent y to the 5th plus 1 equals 2 to the x minus 3. I add the 3 and divide by 2, and so x will be a to the y to the 5th plus 1. That plus 1 is in the exponent. Plus 1, just make it clear. Minus 3, and all of that is divided by 2. Plus 3 divided by 2. And now x is the subject. We can also do algebraic, we can do some solving of equations. If I consider this one, if I want to solve for x, I want the exact value. Well, what do I notice here? That this is just log base 6 squared, which is 5x plus 1. Well, those are inverses, so they cancel out, and I get 2 is 5x plus 1. 5x is equal to 1, so x is equal to 1/5. The next one, make sure you pause it and try it yourself. But if I want the exact value, I can rewrite this, or I can do the inverse of both sides. I like to think of this as doing the inverse of both sides. ln to the x is equal to, so e to this exponent is e to that exponent. These cancel each other out to get 2x is equal to e to the 4th. So x is equal to e to the 4th over 2, and this is the exact value. On this one here, we have ln x equals sine x. Well, these ones said exact value. This one I know I'm not going to get exact value because there's no algebraic way to solve this one. The only way to solve this is to look at a graph. And so if I look at my graph here, I can see from here that that is the point of intersection. And so stealing my picture, I know then that the only thing that x could be is 2.219. This is an equally appropriate way to solve this equation. The last one, solving simultaneous equations. Please pause it, try it yourself before you look at my solution. And if I do it now, what I'm going to do is I'm going to take this, I'm going to do elimination of logarithm base 7 here. I'm going to multiply this equation by 2. So I get 4 log base 4x minus 2 log base 7y is equal to 20. I'm going to add those two equations up, which give me 5 log base 4 of x. These ones cancel, is equal to 35. And so log base 4x is equal to 7 when I divide both sides by 5. And if I rewrite this now, 4 to the power 7 is equal to x. This is my value of x. I could plug it in here and then evaluate for y. And because it's base 4, it will be fairly simple. The other option I could do is as opposed to eliminating log base 7, I could multiply by a -2 here and then add the equations up this way. That would also work. But let me try substituting this into this equation here. So it's 2 log base 4 to the power 7 minus log 7y is equal to 10. Well, this is 2. This are inverses, so it's going to be 7 minus log base 7y is equal to 10 minus log base 7y is equal, well, that's 14. Subtract gives -4. Give -4. 4. And so if I get rid of the negatives, I get log base 7 is y is equal to 4. And if I rewrite this last bit, then y is equal to 7 to the power of 4. And I've solved this simultaneous equations. But consider doing elimination twice, because this one worked quite nicely, but that's not always the case.